This is easier. Does that help? No. Okay. So the rule is you multiply the coefficients. See if I can spell coefficients today. So you multiply the coefficients and then multiply what's under the root sign. You don't combine them. I should put a star here and say indexes have to be the same. Indexes, do you think that looks right? Yes, is F. From, that's right, you think? Okay, all right, we'll go with that. Indexes must so the deal is, again, for division, same sort of thing. You're going to divide coefficients. And then you're going to divide what's under the root sign. You know, I'm probably going to use the terminology, which I made myself. What are the numbers called under the root sign? Ooh. What are those called? Radicands. It might be. This is way easier, so much easier than adding and subtracting radicals. Kind of like fractions, like multiplying and dividing fractions, that's really easy. Adding and subtracting fractions, you gotta find that common denominator. Way easier to do this. So, with that being said, let's jump right into it. Let's multiply it like we never multiplied before. So, what do I multiply first? My coefficients. So I have -3 and -4. What does that give me? -12. Why is it positive 12? I'm so confused. Oh, did I? Okay, sorry. No. No. So -3, +4, -12. There's people be up here. They don't do this. So are the indexes the same? I guess I probably should have checked that first. Yes, they are. Who is that? I'm not going to give you mismatched indexes. Just know that. What's under the root sign? 2x times 6. So I put my root sign. This one's a square root. I got to tell you guys, I'm going to be pretty particular about this. At 12 should not be where the index is. Some of you have messier writing and things get mixed up. I don't know how to say that nicely, but the 12 has to be a coefficient. Okay? 2x times 6, 12x. Are we done? I love that you know the answer is no, but I think because I asked that question, I kind of think the answer is no. What I need to do, what do I need to do? I have simplified. Okay? I know that I can simplify 12. What are the factors of 12 with the largest perfect square? I got 1 and 12. I got 2 and 6. And I have 3 and 4. 3 and 4. So my -12 still stays outside. I'm going to do the root of 4 times by the root of 3 times by the root of x. Now x, there are no factors that are going to give me a perfect square. It's just going to be x. So I'm going to have -12 times 2 times the root of 3x. So my answer is going to be -24 root 3x. This is the answer I'm looking for. Back of the book, I'll have simplified radicals. If you left me with this, there'd be a half mark deduction because you didn't give it to me. just talk about what happened. All right, so everybody looks so happy for Friday. Yeah, stars home opener this evening. Nothing, no plans. So now, just like binomials, like if I had a 3 and then I had an x plus 2, that 3 has to be multiplied by the x and it also has to be multiplied by the 2, right? So the same thing with the radicals. So I'm going to do my first term, so this is going to be 35 root 15. Anybody amazed by that magic? 7 times 5 is the 35. 3 times 5 is the 15. Now 7 times 6, negative 6. Negative 42. All right. That's a very picky today for the record. And root 3 times root 3 is root 9. Anybody see anything we can simplify? The 9. Can I simplify the 15? There's no factors of 15 that are perfect squares. I got 1 15, I got 3 and 5. So I can't simplify it. So 35 root 15 minus 42 times 3. So 35 root 15. This is going to be 126. Did I do my math right? So that's my most simplified answer. Now, some of you are going to say, well, root 3 times root 3 is the same thing as root 3 squared. And I know that they just cancel each other out, or whatever math process goes in your mind. So if you went right from this to this one, like you skip that top line, I'm okay with that. Like you don't have to show me that. I'm going to assume that you know that root 3 times root 3 is going to have an answer of 3. That's not that far away. Okay. Now we're going on to the binomials. Binomials. So you guys have done 8 million of these. X plus 2 times 3x minus 2. We know how to attack that or not. I'm trying to figure out. So 8 times 9, 72. There's 72 before. 2 times 5 is root 10. And as you go through, your numbers are going to start popping off the page more. Like I know 12 has a hidden 4 in it. That's why those perfect squares, when I said you should know perfect squares up to at least 15, it just helps us identify them a little bit quicker. And then I've got 8 times 6 plus 48. And then I got 20. That jumps off the page to me. Why? What's one of the factors of 20? 4. Right, so these are things that kind of happen. And then I got negative 5. So now I have a constant only times by a mixed radical. So first thing you do is multiply the coefficients. So I'm going to have, gotta move over here, a negative 45. There's no root here. So we just use root 5. You can envision, you know, how those invisible numbers, like if I have x squared plus 3x, you know that the a value on this one is the invisible one. You can assume that there's an invisible root of 1. What's the root of 1? What's the square root of 1? 1, right? So, and then I've got negative 30 root 10. All right. So, can I simplify 10? I can. Well, I can, but it's going to give me 5 and 10. No, it's going to give me 2 and 5. And both of those are prime numbers, and there's nothing I can do with them. The only one that jumps off the page that I can simplify is that one. So I'm going to have 72 root 10 plus 48. Can I do this all in one step? Are you guys okay with this? Probably not okay with that, and that's perfectly fine with me. Nobody's yelled at me yet. calculator. Right? Does that make sense to everybody what I did? Because you guys told me that it would be the square root of 4, right? 4 and 5 would be the factors. So you don't need to write that stuff down for me. So I'm going to combine the like terms that I can. Those two I can combine. So what's that going to give me? 42 positive 42 root 10. The radical doesn't change when we're combining radicals. And now I've got some root 5s. 48 times 2, 96, right? So I've got a 96 root 5 here, and I've got a 45 here. Plus 51 root 5. Woo, I skipped a bunch of steps. And I think you're okay with that. If not, we'll talk about it later. Okay, so when dividing radicals, divide the coefficients, then divide the radicands, but only if they have the same index. All right? You ready? 4 divided by 2. 2. Cube root of 6 divided by the cube root of 3. The cube root of 2. Woo! That was hard. Let's flip this. Because this always shows up. 2 cube roots. I'll do it just for funsies. Now it became a little bit more difficult, right? Because it doesn't divide into evenly. Because 4 doesn't go into 2. But it can reduce this. What would this reduce to as a fraction? All of you are excited to put 0.5, 0.5, right? Like that's where all your heads are at. Let's try it with a fraction. So this would be 1 over 2. You guys agree with me? Yes? Mm-hmm. So now 3 does go into 6, right? You did that over here. So the question is, does the cube root of 2, does it go on the numerator or does it go on the denominator? Does it divide evenly in? If I wrote this, 6 divided by 3, what do you get for an answer? You're all comfortable with this. You're all really comfortable with this, which is really this, right? So that's the exact same thing here. So does the cube root of 2, does it live on the numerator or the denominator? The numerator. So this is supposed to be a 1 here. So the way you may see it written is cube root 2 over 2. Because I don't need to put the 1, because it's just a 1 and anything multiplied by 1 is itself. So this would be my answer. Would you be wrong if you did this? No. You wouldn't be wrong. This and this are equivalent expressions. Woo! Be prepared for that because it's coming at you. 2/3, 1/3, 1/5, 2/5, things like that. You're going to get a fraction. Sometimes they don't break down nicely like this. This is a very nice answer. Okay, you ready? Are you emotionally ready? Everybody knows about difference of squares, right? Okay, some people leave you know what. Okay, when I say rationalize the denominator, what that means is I want you to remove the radicals from the denominator. I don't. There's a reason why I don't want to teach this. But I should have asked my department head before I got here. Okay. So when I say rationalize the denominator, I need you to get rid of the denominator on the bottom. No radicals. It's kind of like if you put 1.5 over 2, I lose my mind because that is not proper mathematical notation. There's never be decimals inside a fraction. Your English teacher would lose their mind if you handed in an essay with no capital letters, right? Can you imagine Ms. Horvath, what she would say to you guys if you use no capital letters? Probably, right? So in math, we don't like to have the radicals on the bottom. It's proper notation. This is a bad note. No. Okay. So monomials are the easy ones. Multiply the entire fraction, both top and bottom, by whatever the denominator is. Whew, that's a lot of words. You can do it just by the radical, or you can do it as the entire thing. I'm going to just do it by the radical because that's what I want to get rid of. So what's the radical on the bottom? Root 3. So that means I times the top by root 3 and the bottom by root 3. What's root 3 divided by 3? Root 3. Root 3 divided by root 3. What is it? 1. Have I changed the value of the expression? No, because of anything multiplied by 1 is itself. So this is going to be 5 root 3 over 2. 2 times root 9. So I'm going to have 5 root 3 times by 2, or sorry, divide by 2 times 3. So 5 root 3 over 6. This is improper notation. Okay, I'm going to pause, and you guys are going to do the next one. Okay, so I just went down to Miss Thompson's room. I didn't abandon you forever. I went down to Thompson's room because I said, on the grade 12 provincial, you don't have to rationalize the denominators. So I was like, why am I teaching it to them? But the thing is in calc, you do, and in university courses, you do. So you're going to have to be exposed to it. But no, in grade 12, you should, but you don't have to. All right, so on this one, I just want to make sure I wasn't like giving you more information you didn't need. Because I'm sure you all would have enjoyed just skipping this lesson. Okay, so you okay? You look flush. Are you hot? Okay. So this one, what's the denominator? What radicals in the denominator? Root 2. So that means you're going to times top and bottom by root 2 over root 2. Because this has to equal 1. If you did root 3 over root 2, it doesn't have a value of 1. You cannot change the value of this expression. So this is going to be 2 root 6. And this is going to be 5 root 4. So 2 root 6 over 5 times 2. I'm not actually going to multiply these together. Guess what I'm going to do? Because you got to give it to me in simplest form, right? So I'm not even going to bother multiplying them. So now I'm going to have root 6 over root 5. This is my final answer because it's in simplest form. Yeah? No. How many people did this? They went 2 root 6 over 10. Good job. I'm proud of you. You all did that and you're all brilliant. Nice. But you can reduce this. That fraction can be reduced. What can it be reduced to? 1 over 5. So 1 root 6 over 5. If you left it like this, it's not in simplest form. Okay. Oops. I got excited. I was moving on. Okay. What root is in the denominator? Root 2. So root 2 root 2, and I'm multiplying. So the numerator, this has to be distributed, so it has to go here, and it has to go here. So I'm going to have 2 root 2 plus root 6 all over. Try that again. Oh, a little crazy with the root 4. So I'm looking at 6. There's no factors of 6 that are a perfect square, so there's nothing I can't combine those two radicals because they're not like radicals. So I've got 2 root 2 plus, let me get too far away. I think it was my head that was in the way. Over 2. Now, and for C, some crazy crossing out. Because there's a 2 here and a 2 here. And I did it, I canceled those 2 out. But do you know why it's wrong to do it on this one? You're crazy. The 2 goes into here, but it also goes into here. So you can't just cancel it out. Because yes, you're right, the 2 does divide nice and easily into the first term, but it doesn't on the second term. The only way you could do that is if we wrote it like this, 2 root 2 over 2 plus root 6 over 2. Then you can cancel those out, leaving you with a very weird root 2 plus root 6 over 2. I'm not sure why you would do the extra step when you can just stay here. This doesn't look any nicer than that. If the 2 can go evenly into here and here, then you can get rid of it, but it has to go into both those terms.
A kitten dies every time you cross off those 2's and don't consider the other term.
It's pretty serious. Okay? I didn't want to have to point this out, but all right. Woo. All right, binomial denominators. You ready? Yes. Yes, you are, Stan, you are. Okay. So again, you've got to multiply by what's happening in the denominator, but you're going to use the conjugate, which I'm sure makes perfect sense to all of you, right? I like to call it the difference of square partner, the missing factor. So you multiply it by, if this one says subtract, you multiply it by difference of squares. All the numbers are the same. What's different? One's an add, one's a subtract. So if you have the subtract, what do you need to do? You're doing the add. So whatever you did to the bottom, you have to do to the top. Because this has to have the value of 1. Woo! You ready for the magic? Because you're like, I do not see how this is going to work. But it is because difference of squares. What is missing in difference of squares? That's a difference of square. What's missing? That middle term, I have no x. And that's what I'm trying to get rid of. And it'll make sense when you do the math. 5 times 4 is 20 plus 5 root 6. Numerator looks good. That's easy peasy, right? Denominator. 2 binomials multiplied together. So you have to treat them as binomials. If adding the brackets helps you, please do it. So 4 times 4 is 16. 4 times by a positive root 6 is plus 4 root 6. Negative root 6 times by a positive 4 is negative 4 root 6. Negative root 6 times by a positive root 6. What kind of 6? A negative times by a positive. It's going to be a negative. I'm going to write it in 36 just so we can see the process. Can I simplify root 6? We've already talked about this. Can I simplify root 6? No, I can't. So my numerator stays the same. 20 plus 5 root 6 all over. What do you notice? What do you notice? What do you notice about these two terms? They cancel each other out. They're gone. What's the square root of 36? 6. So I've got 16 minus 6. So 20 plus 5 root 6 over 10. Can I reduce that? What can I take out of everything? 10 goes into here nicely, but does 10 go into here nicely? What factor can I take out of all of these? 5. So if I take 5 out of 20, where am I? I'm at 4. 5 out of 5? 1, so that's just a root 6. And 5 out of 10? 2. No. I mean, you can, if it helps you, but I don't think it. You guys get it? Makes sense? Clear as mud? Cool, this one trips everybody up all the time. Your guys, does it say just root 3 and then the plus 2's outside? Yeah. Okay, so I fixed it on your notes, I didn't fix it on mine. So go with what's on your page. So remember, I'm looking for the difference of squares partner. So my bottom's going to be root 3 and 2. So is it going to be an add or subtract? It's going to be a subtract because I already have the add. So if that's what I have on the bottom, I have to do the exact same thing on the top. This question has appeared on my tests and quizzes, and people always put a plus on the top of the equation. Because then that changes the value of the equation. So on the top, I'm going to have root. So I've got two binomials. So I've got root 9 minus 2 root 3, and then negative 2 root 3 plus 4, all over root 9 minus 2 root 3. The difference here is now I've got a plus. So plus 2 root 3 minus 4. Do we see some differences? Hopefully. You see differences, or am I just making stuff up? So I'm going to simplify this. I'm going to have 3 minus 4 root 3 plus 4 all over 3. What happens to these two? They cancel each other out. If they don't cancel each other out, you have done something wrong. These two terms, all in the denominator, should always cancel out. If they don't, well, start going back and checking your math. So I'm going to combine like terms. So I'm going to have 7 minus 4 root 3 over a negative 1. Would I leave it like that? No, because that negative 1 goes into both those terms. So I'd be left with negative 7 plus 4 root 3. That would be my answer. Yeah. Which one? The answer behind the box. There you go. So I don't care if there's radicals in the numerator. I just can't have a radical in the denominator. A lot. Okay. I want to do on the next page, I want to do example B and C. B and C. Am I good? Can I switch pages? I think you guys could probably do this in your sleep now, right? Maybe? Close. Or so now. Okay. I want to do ones that look a little bit different. So I'm going to use something like a cube root here. So what's the radical on the bottom? The cube root of 9p. So that's going to be what I multiply. So you guys got to get good. You got to get good at writing indexes. You got to write neat enough that I can identify what's an index and what's a coefficient. And I say this out loud just because I have a lot of people who just slap numbers down on pages and it scares me and I just can't tell. I don't want you to lose marks because of sloppy writing. So the numerator is going to be really easy. It's going to be -7 cube root of 9p. Whew, easy peasy. The next one is going to be 2 times by the cube root of 81 p squared. Anybody see my problem? Is 81 a perfect cube? No. Not a perfect cube? That's crazy. Is p squared a perfect cube? So I still can't cube root this. What the hell? The reason why is because with perfect squares, what does 2 to the exponent 3 mean? 2 times 2 times 2. All we did was do this so far. What does that give me? That gives me a perfect 4, which is a perfect square. What do I do to get it a perfect cube? I got to do it 3 times. Factor 1, factor 2, factor 3. What if I had a 4th root? I'd have to do it 1 more time. So that cube root of 9p, cube root of 9p, cube root of 9p, you just cubed it. Does that make sense? So if you had a 4th root, how many would I need? I need 4. So there's my cube root of 9p, cube root of 9p, cube root of 9p. 1, 2, 3. I'm trying to get rid of the cube root, so I need 3 factors. If I have a 5th root, how many factors do I need? 5. This is on the quiz. I'm going to give you a cube root or a 4th root. I'm telling you this right now, although I told you that last time. And none of you listened to me, so maybe I'll stop telling you. So now I have to multiply by that 3rd factor. So -7 cube root of 81p squared all over 2 of the cube root of 7.9. Well, I have those sheets back there. P cubed. So now 729 is a perfect cube. P cubed is a perfect cube. So now my denominator, I've left myself in room. So my denominator, my numerator is going to be -7 cube root of 81p squared. Don't really care if there's a radical on the top. It's supposed to be 7. The denominator is going to be 2 times 9p. So I'm going to have -7 cube root 81p squared. Where I get away from the card, course against over 18p. This is my final answer. So the index really matters. If I have an index of 4, I need to add 3 additional times. This will be on your quiz. So start, you circle around it, take a look at it, make sure you understand it. That's a tricky one. I think that's probably the hardest one, like to remember that rule, but it kind of makes sense. If you have a cube, you got to do it 3 times. Huh. And I said I wanted to do C. Do I want to do C? Yeah? Why not? Sounds like a fun time. Okay, binomial on the bottom. So my factors are the same, 3 root 5 and a 4. Is it add or subtract? It's add because this one subtracts, so this has to be add. Numerator and denominator have to be the same thing, because that has to have a value of 1. So I'm going to have 6 root 5 plus 8 over 9 root 25 plus 12 root 5 minus 12 root 5. I need to make that. Subtract 16. So I have 6 root 5 plus 8. Those cancel each other out over 45 minus 16. I did that all that math in my head. Are you proud of me? What's the square root of 25? 5 times 9 is 45. If you write it out, great. If you skip it, okie dokie too. So I've got 6 root 5 plus 8 over how much? 89? 29. 89. 29 is a prime number, so I can't reduce that. That's pretty good. This would be. Okay, so this says that you get a handout on yours, right? Says that there should be a handout, and then you got. Well, maybe something else for that in your life, so I think I'm going to skip the handout. Don't push it off, because I can reverse this pretty quickly, because the handout is printed.